Welcome back. Our list of topics covered so far is getting longer, covering projections, solid modeling and engineering drawings, mechanisms, and now our most recent topic of assemblies. In the last video, we were introduced to the concepts of assembly degrees of freedom and constraints, and in this video, we are shifting our focus to assembly drawings. Specifically, we'll be looking at the types of assembly drawings that exist and the conventions in assembly drawing preparation. This video, in part, picks up from lecture video 2B on engineering drawings, as both engineering and assembly drawings are part of a larger set of working drawings, which give the complete set of information required for manufacturing and assembly of a product based on a conceptual design. Recall from our previous video that a complete set of working drawings includes engineering drawings, which are also called detail or part drawings, assembly drawings, a bill of materials, and any specifications which are supporting written instructions for fabrication. Engineering drawings are fully dimensioned drawings of a single part, while assembly drawings show the assembly of multiple parts together in the fabrication of a product, which is our focus in this video. These assembly drawings serve to show how parts fit together and how the assembled device functions as a whole. Since assemblies consist of multiple parts assembled together, we usually identify each part instance in the drawing with a balloon label that corresponds to a bill of materials or a parts list, indicating all the components in an assembly and the number of each required. In this door hinge assembly, we can see the balloons identifying each component instance and the bill of materials table at the bottom. This drawing is specifically an exploded assembly drawing where the door hinge is shown in a disassembled state, which is one of three main options we have when it comes to assembly drawing types. This outline or layout assembly drawing is likely most familiar to you based on the previous engineering drawings that we've looked at. As seen for this vise assembly, the outline assembly drawing shows the device in a fully assembled state and in multi-view format, as we've seen before, with the optional isometric view for clarity as well. The outline assembly serves to show the fit and the function of all the parts in their final configuration. However, in some cases, we may want the assembly drawing to illustrate how a device is put together, and that's where the exploded view comes in. As we saw with the door hinge, and with this exploded view of the vise, an exploded view shows the relationship of all parts in an assembly in a disassembled state, which may be helpful in seeing all parts of a device in a single isometric view, and it can also elucidate how parts are put together, which you can imagine is important information for product manufacture and even for maintenance. The third assembly drawing option that we will consider in this video is the sectioned assembly drawing, which serves to show the device in its final assembled configuration, but also with sectioning to reveal hidden components. In this isometric section view of the vise, the sectioning allows us to see screws that would otherwise be hidden from view, and this helps us understand how parts fit together. Also note in this drawing that the different parts have different section linings so that we can easily distinguish them. So we've covered outline, exploded, and section assemblies, which are all useful drawings with different advantages, but they all follow the same general conventions. To start, you may have noticed that hidden lines are not typically used in assembly drawings, and this is even true in the multi-views of outline drawings. You won't see hidden lines there. Remember that the main purpose of assembly drawings is to show how parts are put together, and the inclusion of hidden lines would make these drawings extremely difficult to interpret. If there are hidden features or interior parts that you feel need to be seen, then this is probably a sign that a sectioned or an exploded view is needed. Two examples of sectioned assembly drawings are shown in this slide for valves. To the left, we have a broken out section view where only a portion of the valve is sectioned, and to the right we have a full section view. So these are just two examples of what you can do to see interior parts of an assembly. Another convention with assembly drawings is that dimensions are not typically included. Remember, part dimensions are provided in detail engineering drawings for fabrication, and assembly drawings are just to show how these parts fit together, so there's no need to redimension part geometry on assembly drawings. There are a couple exceptions to this when it comes to including dimensions that specify how parts should be placed relative to each other. For instance, assembly drawings may include dimensions such as the maximum jaw opening of a vise, as seen to the right, although to be honest, this image probably doesn't show the maximum opening. Dimensions may also be included for assembly information when machining or welding is required. Otherwise, if the dimensions are provided in detailed part drawings, then there is no need to repeat them in the assembly drawing. This wraps up our very brief discussion on the types of assembly drawings and their conventions. So now you have the general knowledge to make your own assembly drawings from assembly models. Next week, we will discuss another use of assembly models, not for drawing, but for dynamic simulation instead. So stay tuned for that.